I've chosen for the title here, Unsettling the Science. And by that, I make a distinction between the science that's discussed in the popular and political circles versus the science with a lowercase t and s, which is what we all read in the literature and even in the assessment reports. I don't think anybody doubts that science should inform policies, but it need not determine them because ultimately they express a society's values and priorities. But of course, all of the decision makers today say that they're listening to science. President Biden in the US said on his first day in office, it's the policy in my administration to listen to the science. John Kerry, whom he appointed as climate ambassador, said that there's no doubt in anybody's mind that the science is absolutely certain. That was back 7 years ago. And of course, he's even more certain today that the science is what he believes it to be. We have a number of other people in the political and corporate forums talking about existential threat, climate crisis, climate emergency, climate disaster, whether it is the president, Kerry, Bernie Sanders, Mark Carney, a familiar figure in Europe more than he is in the US, Bill Gates, my good friend Ernie Moniz, all of them talking about the dire climate future that awaits us unless we do something. Globally, we've got the Secretary General of the UN saying upon the release of the latest UN report, it's code red for humanity. But in fact, that appears nowhere in the report. And to home in Ireland, we've got your own Eamon Ryan on the same occasion saying the science is now ever clear, ever unequivocal. If we don't make changes, the cost of inaction, et cetera, et cetera. Well, what science is everybody talking about? It is the science that's written in the assessment reports of the AR6 Assessment Report in 2014 and the sixth report that was released just 2 months ago. And similarly in the US, every 4 years, roughly, it issues its own assessment report. When you read the reports, as I have in some detail, they say many important and surprising things. But I can assure you that most of the decision makers that you saw on the previous chart have not read these reports, or I doubt that many have read even the summaries for policy makers. I'm reminded often of a line from the classic movie, The Princess Bride, where one of the characters, Vizzini over here, keeps using the word inconceivable. And the main character gets kind of annoyed with him, Inigo Montoya, and he says, you keep using that word. I do not think it means what you think it means. And in the same way, I do not think the science says what most people think it says. Let me give you some examples. When you read the Climate Science Special Report, you see that heat waves in the US are no more common now than in 1900, and the warmest temperatures haven't risen in the past 50 years. Global wildfire area has declined more than 25% in the last 17 years, and 2020, the last year on record, was among the least active years. Greenland's ice sheet isn't shrinking any more rapidly today than it was 80 years ago, when human influences were much smaller than they are today, said a paper published in Nature last year. And there are no detectable human impacts on hurricanes over almost a century of record, and I'll show you some of that in detail. And then maybe most surprising to me, when you read it and understand it, both the UN report and the US assessment reports say that the net economic impact of 6-degree warming, and remember the Paris discussion is about 1.5 or 2 degrees, if we warm by 6 degrees, the net economic impact is projected to be minimal. There are statements like these and many others that you find in the report that belie the canon of climate catastrophe, namely that we've already broken the climate and face certain disaster unless we act promptly on an enormous scale. Now, you might ask yourself, how did the science in the reports get turned into the science that the politicians discuss? And the answer is it's a long game of telephone. It starts with the observational data and the research literature. It goes on to the assessment reports themselves, further distilled into the summaries for policymakers, then on to the media and on to the decision makers and the public. And in this long game of telephone, there's ample opportunity to distort the message. There's the confusion of weather with climate. There's the confusion of climate change with a changing climate change being popularly associated with human influences. They highlight recent trends without historic context. They look at extreme emission scenarios in the future and call that business as usual. And I think as many people in the audience have experienced, there is suppression in the public forums of legitimate divergence from the consensus. The word denier is often bandied about. And the reason I was inspired to write the book that Jim referred to was to try to short circuit this chain and give non-expert readers a sense of what the assessment reports actually say. Almost everything in the book is straight out of the assessment reports up through AR5 and the original research literature up through the end of 2020. And so what I thought I would do in part in the next set of remarks is to update you a little bit on my take on some of the AR6 points that are made, and then offer some further thoughts that aren't in the book. So one of the surprising aspects of the current generation of models, CMIP6 as they're called, is that about 40% of them are more sensitive to carbon dioxide or generally to human influences than was previously estimated in the fifth assessment report. This is somewhat disturbing because in fact one would hope that the models are converging with each generation rather than becoming more uncertain. And these very high sensitivities are in fact quite implausible physically. I wondered in the book about how AR6 was going to deal with these high sensitivities, and here's what they did. It turns out that the sensitivity is related to something called the climate feedback parameter, called lambda, and that lambda can be decomposed into a sum of different processes. And then what the people who put together AR6 did was to separate out the different processes associated with water vapor feedback and lapse rate, surface albedo, biggest the which every model has just about right. Look at them, other observational information, and then combine it to get some better estimate of the sensitivity. And here is what it looks like when you get to the report itself. The models give you this together with the processes, and then you put in some other observational data, and you get an assessment of the net sensitivity, which is in fact somewhat narrower. One of the issues that's quite interesting is if you've decomposed the sensitivity into these various processes and then put it back together again, how come the models don't give the same answers back again? That suggests that there's something wrong with the models, or we're something in how these sensitivities interact with them. Another thing that's quite interesting then is that the range of sensitivity has narrowed over time. Again, this is a figure from the Carbon Brief that summarized it down in a serious way in 1979. And you can see that the latest AR6 goes anywhere from 2.5 to 4, with a best value of 3, whereas AR5 went from 1.5 to 4.5. So the low sensitivity is chopped off, but also the high sensitivities. I think the next big news is that when you look at the various emissions scenarios for future emissions, you get a range of scenarios ranging from a very low emission scenario up to a very high carbon heavy scenario. And then you look at the probability distributions associated with the warming from the present, let's say, up to the end of the century. And of course, the heavier emission scenarios result in more warming. And what's interesting about AR6 is that previously in AR5 and other reports, they would never say which emission scenario they preferred. They were all deemed equally likely, if you like. And in the present report, they have said that the heavier ones, 7 and 8.5, are unlikely, and in fact, more likely would be 4.5. So if we focus in on 4.5, what they say is that we have seen warming since 1900, roughly, of 1.1, and the best estimate of 4.5 is about another 1.7 degrees with a probability distribution as shown like this. So not so much of a catastrophic scenario as we will see, and exclusion of more extreme changes in the climate. So now you start reading the rest of AR6, and what I have taken away is it's very wordy, and you find very few graphs that really tell the story of what the science says. I'm going to go through a couple of them. The first one I want to talk about is sea level variability. This is, I think, the only graph of sea level that you find in the report. Here is the historical value. This is global mean sea level relative to 1900. And you see the historical trades going up rather gently, and then projections under various emission scenarios out to 2100. And of course, some more extreme scenario in which ice sheets disintegrating rather rapidly under the most extreme scenario. And when you look at the text that accompanies that in the summary for policymakers, it says sea level increased by 0.2 meters between 1900 and the present, and the average rate of rise was 1.3 millimeters a year between 1901 and 1971. So over 70 years, the average was 1.3. It increased to 1.9 in the last 40 years or so, and further accelerated to 3.7 millimeters a year in the last 12 or 13 years with high confidence. That statement is entirely misleading, because when you look at the actual sea level rate of rise in this figure from a paper that is cited in the IPCC, published in Nature last year, you look at the observed trend, which is the blue, actually oscillates an awful lot. It is currently high, that's true, at 3.2 millimeters a year, up to 2015, I think, in this paper. But then it was similarly high in 1940, where it was about 2.4, 2.5. It went through a minimum and went up again. AR6 does not mention this at all, in part because I don't think we've got a very good explanation for these oscillations. Entirely not consistent with scientific integrity. And what's even more amusing is when you look at the projections of what sea level will be, I would term them extraordinary. I live in Manhattan some fraction of the time, and so I've been very interested in the sea level trends at the Battery. This is the historical trace from 1920 up to the current. These are 30-year leading trends. And what you discover is that, well, there are oscillations. That's kind of interesting in and of itself. But then you go to this NASA webpage, which projects sea levels at any location you like around the world. And I could have taken Holyhead. And of course, on the NASA website, you can see that previous estimates show that human activities are responsible for 70% of the observed sea level rise, with the percentage approaching 100% as time goes on, completely ignoring natural variability. Very little is happening with hurricanes. I think many of you may be familiar with this 50-year record of tropical cyclone frequency on the top globally, and hurricanes on the bottom, a little bit up and down, but no clear trend. And similarly for the accumulated cyclonic energy, which is a measure of hurricane activity, if you're not familiar with it, lots of ups and downs, but again, no clear trend. And in fact, the Climate Science Special Report in 2007 buried on page 258 the statement that there's low confidence in any long-term multi-decadal or centennial trends in activity. And then there was a paper with 11 expert authors in 2019 who said we can't find anything except for a slow poleward drift in the Northwest Pacific Basin. Low confidence in any other reported changes. What does AR6 say? Well, buried in 11712, low confidence in most reported long-term trends. You go to the technical summary, it's likely that the proportion of intense tropical cyclones has increased over the last 4 decades and can't be explained by natural variability. And then somewhere else in chapter 11, increases in the proportion of major tropical cyclone intensities is consistent, and we sort of see it. The basis for that is a paper by Koonin et al. In 2020, and they analyzed satellite imagery to infer that the proportion of major hurricanes, Cat 3 to Cat 5, globally went up significantly. They see it here in the various basins, strong signal in the North Atlantic, and so on. On the other hand, in the paper, they say the large trends in the North Atlantic are linked to observed regional multi-decadal variability. And then this complicates the detection. Significant trends that they identified don't constitute a formal detection and can't precisely quantify the contribution from anthropogenic factors. Well, Kerry Emanuel, a hurricane expert at MIT, I expect many of them you know, took me to task for saying that there were no long-term trends, quoted this paper by Koonin et al. And said, this proves that there are human influences. Well, if you read the paper, that's not quite true. AR6 thinks it's true. But then just a couple months ago, another paper was published in Nature by Gabe Vecchi and collaborators, in which they did a reconstruction of historical observations of hurricanes back to 1860. And what they found was this fraction of major hurricanes, the recorded or the dashed, and their adjustment for missed storms, mismeasured storms. And that rise in the end is what Koonin et al. Got so excited about. Actually, Kerry got so excited about. This is the record of accumulated cyclonic energy in North Atlantic through yesterday, and more climatology, a little bit above. And globally, or at least in the Northern Hemisphere, which is globally for this time of year, it's actually less than normally active. So every time you hear the weather presenter talk about hurricanes and how they're getting worse, it's certainly not obviously true. I want to say a few words about recent weather extremes, if I could. In the media this summer, we've heard about heat wave in the Northwest US that CNN said was virtually impossible without the human-caused climate crisis. We've seen the floods in Europe, described by the New York Times as the latest sign of the crisis. We've seen summer floods in China, as well as in Europe. The climate connection between deadly downpours around the world, go to the Washington Post. New York Times put in the fires and the floods and dead fish. There will be no return to normal. And the Boston Globe, as usual, trumped everybody, said, welcome to the climate apocalypse. It's going to get worse. You know, whenever I hear that kind of stuff, I remind myself that climate is the statistical properties of weather, and it plays out over decades. And here I want to remind you or tell you about the data on the height of the Nile, taken on an island in the middle of Cairo. That's what the structure looks like today, the rotonilometer. And if you go inside it, you see this long vertical chamber with 3 outlets to the river and a central pillar marked in cubits. And the Egyptians built this in the early 7th century and had been recording the height of the Nile every year, both maximum and minimum, obviously of great interest to them. It's a wonderful direct observation record of a climate variable extending over 900 some odd years. The annual, so I should say that the Nile drains about 10% of Africa, which is 1/3 the area of the US, and its minimum height is a great measure of the level of Lake Victoria, which feeds the Nile and of course drains a big part of Africa. And the annual data are the blue lines here from Professor Kotsayanis. And what's interesting, of course, is the great variability from one year to the next. Look here, it was up at 4.5, and the next year it was down at 0.8 meters. But even if you take a 30-year average indicated by the red line, there are lots of ups and downs. And I imagine to myself some medieval climate panel in Egypt looking at this decline and saying, my gosh, first of all, we've got a new which I've tried to write there in Arabic. And secondly, we'd better do some prayers and sacrifices in order to get things back to some more familiar regime. And of course, it did return to something more familiar, and even then some, if you just wait long enough. So it's kind of hard to get excited about what happens even over a 5 or 10 year trend. If we look at the Northwest in the US, where we saw the record high temperatures, John Christie put together these data, which show the number of daily records per station over 100 years in the US as a whole, which are the black, and in Oregon and Washington, 26 stations in those states. And it's really hard to see any trend at all over decades, which is what you would need if you're going to say climate. Let's say a word about precipitation extremes. The latest UN report says we see intensification of extreme precip at the global and continental scales, with a robust increase of the one-day precipitation over the land, but there's a lack of systematic analysis of long-term trends at the sub-daily extreme precipitation. And in North America, extreme precipitation has likely increased since the 1950s, but with regional diversity, and future projections are highly uncertain. Precipitation is very much a local phenomenon. A couple of weeks ago, we had an extreme precipitation event here in New York City. You may have read about it. And it was the greatest precipitation on record in Central Park in Manhattan for a 1 hour period. Unfortunately, you can't get 1 hour data going back, but you can get 1 day data going back quite a bit. And so I looked up the 16 greatest rainy days in Central Park from 1869 to the present. Apologies to our European friends that the scale is in inches, but this is the US. And if you look at the most recent event, it was over here at 7-point-something inches for a day. There are 4 other events that were rainier, the rainiest going back to 1870-something, 79, I believe. And then the next tier of the other 11 are down at about 5 inches. You'll notice that there is no clear trend in either magnitude or duration as you look at these data. And in fact, it's kind of fun if we're going to give these charts out later on. You look up the record point rainfalls in the US for different intervals, and they are all over the map, both in terms of when they happened and where they happened. So precipitation, highly local, highly variable. Hard to say it's climate. If you look at what AR6 said about floods, there's high regional variability and lack of overall significance. Some regions are experiencing increases in peak flow, other regions experiencing decreases. You can look up the data for Germany. There's a paper in 2020 that basically said there's no long-term trend in heavy rainfall days across Germany. There's the map. And again, no clear pattern over the decades. But of course, there are these regional and temporal variations. I want to say a word about fires, drought. In AR5, they said there was low confidence in a global trend in drought or dryness. In AR6, there's a more elaborate discussion about drought. And what they said is that climate changes contribute to increases in agricultural and ecological droughts in some regions, with medium confidence, not a tremendously strong statement. Here is the Palmer Drought Severity Index over about 130 years, 120 years in the US, no clear trend at all, not wet nor dry in either direction. On the other hand, we'll do changes in the regions. This is the annual flow of the Colorado River in the 2009 National Climate Assessment, and they point out that there have been some droughts in the Southwest that have been more severe and longer lasting than any we saw in the 20th century. You don't see that at all in the most recent reports. Here's the actual drought severity index again for the Southwest, and you can see regions here at the end of in the middle of the 12th century, where it got pretty dry, just all on its own. If you look at California over the last 130 years, you can see that in the last few decades, there is maybe a gradual drift toward drought since 1900. So of course, that drought gets blamed a lot on fires. Fires are blamed a lot on that drought. But if you read the Climate Science Report of 2018, it says state level fire data over the 20th century shows that the area burned in the Western US decreased from 1960 to 1940, was low in the 1970s, and then increased to more recent years. Here's the data. The government did not, until about 5 or 6 years ago, offer some caution about the early data. Now they have, but anyway, you can see that the forest area burned in the early 20th century was about 5 times what it was in the 1980s, and it's kind of been gradually creeping up a little bit. Well, how could the fires have declined so much, even as there was no drought going on in the US, according to the indices? The answer was human influences, and you imagine. The US started in the 1930s a deliberate policy of fire suppression. Those of us who are old enough and lived in the US remember Smokey the Bear. The slogan was, only you can prevent forest fires. And the Forest Service did not start any deliberate burns, nor did they allow anything that popped up on its own to continue burning. The consequences of that fire exclusion policy are evident in this pair of pictures, the top one from 1900, the lower one from 1981. This is a scene in Montana. You can see this whole ridge here is now covered with trees. So if you let the forest grow and then it gets dry, it's obviously going to burn. And so the recent fires we've seen are some combination of forest mismanagement, development that put towns and buildings in forests, like Paradise, California. Many of the trees in California have died because of a bark beetle infestation, and so burn more easily. And the drought conditions clearly played some role, whether that's a natural variation or anthropogenic, who knows? All right, let me talk a little bit about the economic impact of warming. I mentioned this early on, and for me, this is one of the amazing things hidden in the reports. If you read the National Climate Assessment in 2018, in chapter 29, they say that climate change is projected to impose substantial damages on the US economy, and that's going to grow to hundreds of billions of dollars by the end of the century. They offer this chart, which is a measure of annual economic damages at the end of this century under a high emission scenario versus a low emission scenario. And what is amazing to me is that this is a 70-year projection of high granularity. Look at that, air quality, fresh water, bridges, and so on. And it's given to 3 significant figures. All right. Any scientist looking at that would say, you don't get a passing grade, yet this is allegedly the best science that the US government puts out about climate impacts. And of course, this report generated dire economic headlines. NBC News said climate change will wallop the economy. Even Fox News said grim economic consequences. Climate change could cost the US billions, said the FT. New York Times said report warns of damaged environment, shrinking economy. Well, if you actually look at it, it isn't so bad. This chart from that same report shows economic damages as a function of global temperature rise over the 21st century and the percent impact on the US GDP. And you can see that for a rise of 9 Fahrenheit, which is 5 Celsius, and this is relative to the present, so 6 relative to pre-industrial, you can see you get an impact of about 4%. Bjorn Lomborg more recently has summarized the same sort of data, and it's again a few percent for a few degrees of warming. So think about 4% for 4 or 5 degrees of warming. That turns out to be a bump in the road. And the IPCC knew that, but never highlighted it. Back in chapter 10 of Working Group 2 in AR5, it says the impact of climate change will be small relative to other drivers. And they give us a chart comparable to what I showed you before. Well, it's pretty easy to do a simple calculation. Here's the real US GDP. Historically, it grew by a factor of 20 since 1930. There's the growth rate. It averages 3%. The OECD itself says that the US economy is going to grow over the next 40 years at 2%, the world economy about the same. And so you can ask, if I take all growth rate, which is this blue curve, or subject to a 4% climate impact or a 10%, you get these either orange or gray curves, and you can see it's the delay of a couple years of growth. So I would love to ask Bill Gates, Bernie Moniz, people who might understand this, is this the climate crisis you're talking about? Or what exactly is it? A couple of people criticizing my discussion of this has said, well, what about tipping points? Ago that analyzed 8 different tipping points. And you can see them listed there, the permafrost emitting methane, the Atlantic DMOC slowing down, etc. And they add about another % or 2 to those estimates. So we're still talking about less than 6-7%. And then people say, well, what about the fat tails? And Richard Newell and collaborators published a paper quite recently in which, if you just focus on these models, which is what they trust, they say that for a warming of 4 degrees centigrade in 2100, they see impacts again of, well, somewhere between 0 and 5% without that fat tail. So again, if you believe this, and those of us who understand models maybe don't believe it, but it is what the official science is saying, and it should be made evident to the decision makers. Okay, let me turn to the societal response in the last section. This is a complicated business. You got to fold in the certainties and uncertainties in the science, values, risk tolerance, geographical intergenerational equity, development of most of the world, and then technology, evolution, economics, regulation, and so on. The world has, of course, been focusing on mitigating or reducing greenhouse gas emissions, but fossil fuels are burned to meet current and growing energy demand. They're not burned just because. Most of the world is developing. The 40% of the world, 3 billion people, don't have adequate energy. And despite the declining costs of wind and solar and other renewables, a reliable source of energy. I'll discuss that in a minute. Human influences on the climate continue to grow as CO2 emissions grow, and those emissions accumulate in the atmosphere. And you can see that most of the emissions are now coming not from the advanced economies, from the rest of the world, and that disparity is expected to increase as the rest of the world continues its development, as it should. And you have to remember, if you're not an expert, that to even stabilize human influences, global emissions have to vanish by mid-century, just 28, 29 years from now, if we want to hold the temperature allegedly to 1.5, or by 2075, if you want to hold it to 2 degrees. I've said it politely here on the chart. It's unlikely the world will do that. I said it in the book. It's a near impossibility the world will do that. But let's look at what at least the US is planning to do. Similar discussions going on, perhaps even more stringent in the EU. Biden's plan is to reduce total greenhouse emissions, net greenhouse gas emissions, by 50% by 2030, and to go to net zero by 2050. These are relative to the peak in 2005. The sub-goal is to reduce power sector emissions to zero in the next 14 years. To eliminate the sale of gasoline and diesel vehicles within the next 14 years, and impose restrictions on new domestic oil and gas production, even as he's asking OPEC to increase its own production. And what you see is that climate risk is being infused into all aspects of the government, especially into financial matters. But what I think many people don't realize, oil and gas employs about 10 million people in the US. It's 8% of the GDP. There are 1,800 fossil fuel plants in the US. And so if you want them all to disappear by 2035, decommission 11 a month in the next 14 years, 280 million vehicles have to be replaced. So the pace and scale that's what's being proposed will degrade reliability of the grid and fuel supply, especially as vehicles become electrified. We're seeing assets destroyed, the value of generating assets, the grid, fuel and vehicle infrastructures. Fission is going to be essential if we're going to have a reliable grid with zero emissions. It takes forever to build a fission plant in this country. The storage technologies don't exist yet. We're going to see growing energy insecurity as we import more oil and gas. I think, as we're already starting to see in Europe, there is going to be a citizen backlash as these measures start to bite. Even more so as people realize that the US is a shrinking fraction of global emissions, only 13% currently. I think the EU is even less than that. And they're going to ask the question, tell me again why. And I don't think there's a very good answer right now. I want to say some remarks just in closing now, almost done, about the cleaning up of the grid, or the decarbonization of the grid, which is a major push in the US and in Europe, an essential push if the economy is going to completely decarbonize. There is a trade-off. Of course, the push is to get the grid to be clean, then with zero emissions. But at the same time, you want it to be inexpensive. It shouldn't cost a fortune to deliver electricity. And it also needs to be reliable. And these three desiderata are in tension with one another. If you want an inexpensive but reliable grid, which is pretty much what we have or had in the EU, then it's coal and gas, and they work just fine. If at the same time you want it to be clean and inexpensive, wind and solar are getting a lot cheaper. And yes, per kilowatt hour generated, they beat in many ways coal and gas. On the other hand, if you want the grid to be reliable and low emissions, you have to think about storage and carbon capture and storage. So if you want to take the grid to which many non-experts aspire, wind and solar, and start to make it reliable, you need to add these elements in. And when you look at the cost analyses, some of them using real weather data to handle the intermittency of solar and wind, you discover that the biggest cost of a green grid is not generation, but reliability. And I don't have to tell you all of that for those of you who are living in Europe right now, or for people living in California. The cost of ensuring 3 or 4 nines reliability pushes the cost of the grid up by factors of 5 to 10 with current technologies. So how do we get there? Who knows? The other thing I wanted to remind people is that mainstream economics says that there's an economically optimal pace of decarbonization. This graph from a recent paper by Bjorn Lomborg, it kind of illustrates it if one just ignores the detailed numbers for a minute. If the policies are too stringent, you incur costs by decarbonizing too rapidly, both because you deploy immature technologies and you disrupt society a lot faster than it would like to change. On the other hand, if you don't decarbonize rapidly enough, you start to incur greater climate risk to the extent that you believe CO2 creates climate risk. This was realized by Bill Nordhaus already 25 years ago. He won the Nobel Prize in 2018 for that realization. And this from his Nobel Prize lecture says the economically optimal pace of decarbonization allows the global temperature to rise 3.5 degrees from 1900, whereas Paris is talking about 1.5 degrees from 1900, let's say, all right? So the politicians and policymakers have gotten too far out over their skis compared to what mainstream economics thinking says. And Ross McKittrick put out a wonderful paper with Murphy about this recently, explaining it to me and others who have not really understood this in some detail. All right, my own thinking is that adaptation is going to be the dominant response. It's agnostic. It doesn't matter why the climate's changing. It's proportional. You do more or less if the climate changes more or less. It's local measures have a much harder time buying something that's going to affect things 2 generations away and halfway around the world. It's autonomous. It'll happen on its own, and it's effective. But adaptation is much easier if you're richer. So the best strategy is, of course, to make the developing world as rich as we can make them. And that means providing them with adequate energy. Okay, a couple of sort of higher level strategy comments in closing. Those of us who understand the science, and I expect many of you in the audience do, we must not allow climate science to be Gruberized. And what do I mean by that? Jonathan Gruber is a professor of economics at MIT. He was one of the principal architects of the Obamacare Act, or the Affordable Care Act, that changed healthcare in the US in the Obama administration. And Gruber said in 2014, very proudly, lack of transparency is a huge political advantage. It was really, really critical to getting the Affordable Care Act. At least one key provision was a very clever basic exploitation of the lack of economic understanding of the American voter. We must not allow that to happen, and it is happening with respect to climate science. Misrepresenting the science, whether it's in the assessment reports, the media, or the political dialogue, in an effort to persuade rather than inform, takes away the public's right to make fully informed decisions, distracts from our needs, and there are surely many of them these days. It tarnishes the reputation of science as it makes input to other important policy matters, and it depresses young people. 1/3 of the young people in the US don't want to have children because they think that the climate is going to take the world down. And that's really why I wrote the book. Let me summarize, and this is the last chart. We've got limited observations and poor understanding, so we really can't usefully quantify what the climate's going to do. Even as human influences have grown 5 times in 1950, since 1950, almost all severe weather phenomena remain within past variability. As has reminded me, human welfare over the last century improved on an unprecedented scale, even as the globe warmed by about a degree. Projections rely on models that are really not fit for purpose, particularly at the regional level. When you look at the demographics and the economics and technology, we're unlikely to even stabilize human influences by this century, and we really need to be paying much more attention to thoughtful adaptation. If we are going to mitigate, we need to do it thoughtfully and gradually. And I would close by just noting that precipitate climate action is a far greater threat to society than climate change.